Welcome to This Explainer. Today, we're diving into something that literally impacts every single one of us, but honestly, it's usually totally misunderstood. We're going to look at how one single tiny oversight can bring massive global systems right to their knees. Let's get right into it. We constantly see these terrifying headlines, right? Hospitals paralyzed, banks hacked, personal data just dumped on the dark web. And when we read that stuff, it's so easy to picture hackers as these all-powerful wizards casting complex digital spells to break into impenetrable fortresses. But the truth? Well, it's actually way less magical, and to be honest, a whole lot more grounded in everyday reality. So here's the real kicker. Almost every single major cyber disaster boils down to one simple thing: vulnerabilities. And no, these aren't mystical backdoors built by criminal masterminds. They're usually just tiny human errors. We're talking about a quick typo in a line of code, an everyday device that somebody just forgot to update, or maybe an unnoticed little software feature. It's these incredibly boring mistakes that act as the perfect front doors for catastrophic, world-halting damage.
Chapter 1: The Digital Building.
To really wrap our heads around this invisible digital world, let's compare a complex computer network to a high-security physical building. Just like a real-world building relies on security guards patrolling the outside, your digital setup uses firewalls. The door locks on that building? Those are your passwords. That heavy, fortified main gate? That's your VPN. And all these layers, they exist for one reason: to protect the incredibly valuable safe deep inside, which in the digital world is the main server housing all your data. And this analogy brilliantly illustrates what a vulnerability actually is. See, a vulnerability isn't about a hacker aggressively smashing down that heavily guarded front door while sirens blare. Not at all. It's simply them walking around the perimeter and finding a hole in the wall. A hole that the original architect completely forgot about during construction. The hacker doesn't even need to fight the guard. They just slip right in through the gap.
Chapter 2: How are these holes made?
So how exactly do these invisible holes get there? Like, who is leaving the wall unfinished? The source material neatly categorizes these into three main types: coding errors, memory management errors, and design errors. But here is the staggering reality. Roughly 90% of all vulnerabilities globally come straight from type 1. Just simple, everyday human coding mistakes. I mean, we're human, right? We make typos. Let's look at a concrete example of a coding error. Take a classic SQL injection. Imagine a normal login box on a website, but the developer forgot to tell the system to strictly check what the user is typing in. By typing a tiny string of database logic right into the username box, something like or 1 equals 1, it completely tricks the backend database. The system does the math, sees that 1 always equals 1, and goes, oh, okay, this must be a perfectly legitimate user. It just bypasses the password entirely and lets the attacker waltz right in. Crazy, right? Or consider memory management errors, like the infamous buffer overflow. Some programming languages actually require the engineer to manually manage the computer's memory. If a system is built to expect exactly 8 bytes of data and an attacker feeds it slightly more data than it was built to hold, boom, it crashes. And in the chaos of that crash, the attacker can hijack the program, immediately executing their own remote code and taking over the entire server. And then sometimes the hole in the wall isn't a coding typo at all. It's just a remarkably poor design flaw right from the manufacturer. Think about the millions of cameras, DVRs, and routers that ship out of the factory with their default unencrypted passwords set to simply admin for the username and admin for the password. Anyone scanning the internet can pull up the login page, type in admin, and instantly take control. It's just a massive, massive oversight. Chapter 3: The Anatomy of an Attack. Because the hole doesn't just attack you on its own, someone actually has to find it. Let's look at the actual playbook a hacker uses to exploit these forgotten holes. It's highly logical. Step 1. Attackers use automated tools to constantly scan the entire globe, just looking for open ports or outdated services. Step 2. They confirm a specific flaw exists on your machine. Step 3. They implant malicious code, maybe ransomware or a backdoor. And finally, Step 4. Lateral movement. Let's focus on that crucial final step for a second. Lateral movement is exactly how a single compromised office computer snowballs into a total corporate meltdown. Once hackers squeeze inside that initial forgotten hole, they don't just hang out on that one vulnerable printer or old laptop. No, They move laterally. They spread out, they steal administrator credentials, and they take over other highly secure servers across the entire network until they own absolutely everything. Chapter 4: Global Cyber Disasters. To truly understand the real-world stakes here, we have to look at three massive cyber disasters caused by these microscopic errors. This really illustrates how a single vulnerability scales up. In 2017, the WannaCry ransomware exploited a Windows bug, paralyzing over 200,000 computers globally and literally bringing trains to a halt. In 2016, the Mirai botnet used those default admin passwords we talked about to weaponize household cameras, causing massive internet outages. And then there's the middle example on this list, Log4Shell, which absolutely deserves its own spotlight. Perhaps the most terrifying event in recent memory was the 2021 Log4Shell disaster. Get this, just typing a specific, bizarre string of characters into a simple Minecraft game chat box or an app's search bar could exploit a hidden logging flaw in Java. Doing that gave hackers complete remote control over the server. It threatened global gaming, cloud apps, finance, and e-commerce all at once, literally just from pasting one single line of text. Chapter 5: The Complexity Trap. Now, if the stakes are really this high, you're probably wondering, why can't companies just scan their code, find all the bugs, and fix them once and for all? Well, the answer is staggering complexity. A modern website isn't just one piece of code written by one guy in a basement anymore. It's an intricate, incredibly fragile web of thousands of interconnected systems. You've got front-end displays, back-end servers, APIs talking to each other, databases, and literally thousands of open-source packages. No single human brain can comprehend the entirety of a modern enterprise app's code. And all this complexity leads us to devastating supply chain attacks. This is a terrifying scenario where your own engineers could write perfect, flawless code, but you still get breached. Why? Because a tiny third-party component you imported to do something simple, like manage your text logs, had a hidden flaw inside it. Essentially, you inherit the vulnerabilities of every single tool and package your system relies on. It's like a digital house of cards. Chapter 6: Defending a Complex World. Okay, I know it sounds a bit bleak, but despite this overwhelming global complexity, the source material actually outlines clear, structural ways organizations can successfully defend themselves. It basically comes down to rigorous digital hygiene. It starts with obsessively applying regular system updates, because honestly, half the time, the manufacturer has already fixed the hole. Then you have the principle of least privilege, meaning severely limiting user permissions. Network segmentation is also absolutely crucial. Isolating the office Wi-Fi ensures that an infection in HR can't just jump over to the critical database. Toss in some active defenses to block malicious behavior, and proactive scanning to find the holes yourself. Ultimately, as we wrap up this explainer, we really have to fundamentally reframe how we view cybersecurity. There's this great quote from the source material: "Humans will always make mistakes. As long as systems exist, vulnerabilities will exist." We just have to accept the basic truth that humans are flawed. We type things wrong, we forget to check boxes, and therefore, digital perfection, it's just impossible. So what's the big takeaway here? The true proactive objective of modern network defense isn't achieving this impossible, mythical zero vulnerability state. The real goal is simply outsmarting the attackers to discover those hidden holes in the wall first. The question you have to ask is, can your organization scan for, find, and patch its vulnerabilities faster than a hacker can exploit them?